Welcome back everybody to the real part 5 of our Unity stealth game tutorial series. We have our guards and cameras set up. Now let's go ahead and add a field of view so they can detect the player and trigger a game over. When you're ready, put on your sneaking suit. Let's crack on. First, let's talk about the method we're going to use for the FOV. We're going to use a raycast. But we don't want the raycast to detect the player from any direction. We only want it to detect the player while they're in view of the enemies. And to do that, we're going to use the position of the player and that of the raycast on the guard to create an angle. For example, let's say this angle is 60 degrees. Only when the player is within that angle does the raycast know what to detect. If it hits the player, we'll enter an alert status and result in a game over. If the player is not within that cone, that field of view, then we can't detect them. Or if the player is behind an object, then the raycast is ultimately not hitting the player first, but the cover object. That way we are free of detection. So let's get set up and put this into action. Okay, let's talk about the setup. If you remember, in the previous videos about the camera and the guards, we have a few child game objects attached to them. In the guard prefab, we have our inactive alert. That will become active when we detect the player using the raycast. The raycast will be shot from the FOV point, that is at the base of the guard. The reason we have it here is so that no matter which direction the guard is moving, the length of the raycast is going to be equal. If we had it at the head, when the guard's moving down, it's going to be further away from the player. When the guard's walking up, it's going to be closer to the player, and that's a little bit uneven. Likewise with the camera, we have the same, the alert and the FOV, and the FOV is just at the standard position of the camera parent itself. Let's go ahead and give it an icon. There we go. So this is the point where we're going to shoot the raycast. Let's go back to the inspector here. Let's open up and create an FOV or field of view script and open it up. Okay, for the variables, and there are a few, we will start with a public vector2 called look direction. This will match the movement and the facing direction of the enemies, but for now, we'll set it as a vector2.down. Then we'll have two public floats. One we'll call FOV angle, we'll set that as 60, and one called FOV range, which we'll set as 5. We'll also want a public transform ray point. This will be the point from which we will shoot the ray. Then below, we're going to want to have a serialized field transform target. That'll be the player as the target. And once we've detected the player, we want that alert icon to be active. So we'll make a public game object alert icon. And we'll also want to communicate with the game manager, which we will create after this. And we'll have a serialized game manager called GM. Alright, with the variables in place, let's go ahead and create a void awake where we'll make a reference to them. We'll start with the target, and that will equal the GameObject.findObject of type with the player controller script. Now, we're not going to get the player itself, but we're going to get that base collider. The reason is, the player has a much larger collider, and that's going to make us far too easily detectable. For added accuracy, we just want to get that child object, that base collider in the player. So after, we'll put .GameObject.transform.getChild 0, meaning we're getting the first child in that player hierarchy. Then, again, for the ray point, we have that already attached to our enemies, and that'll be this .GameObject.transform, and again, it's the first child in the enemy hierarchy. So we'll get child and then a 0. And of course, the GM will equal find object of type game manager. All right, with that in place, let's head down to void fixed update where we'll punch in the raycast. But first, we want to have a few more bits of information. We want a vector2 called target direction, and that'll equal the target.position, the player's position, minus the raypoint.position. Then we want to have an angle for that FOV cone, and that'll equal a float angle of direction, and that'll equal a vector2.angle. Now what this does is it takes two vectors and returns the unassigned angle between them. So the two vectors we want will be that target direction and our look direction vector2 that we had in our variables. And that will return it as the desired angle. Then let's go ahead and punch in our raycast. Our raycast hit 2D called ray will equal a physics2d.raycast, then the point we want the raycast to be shot, the raypoint.position, towards our target direction, and we'll assign it the FOV range. With the raycast set, we need to give it some information. We need to tell it what objects to detect and what objects to ignore within that cone of vision. So for that, we'll use an if statement, and we'll say that if the angle of direction is less than the FOV angle divided by 2, and the ray.collider is not null, meaning that the ray is active, then inside we'll have another if statement, and this will say that if the ray.collider.tag, so the object that the raycast is colliding with, does not equal the tag of player, then we'll have a little debug just so we know they're not looking at the player. You can call it whatever you like. I've gone ahead and added a cheeky Metal Gear reference to, no one there. And we can change the color of the raycast. Else, if the object we're hitting is the player, then we go into alert and we want that alert icon .setActive true, and we'll call upon the game manager's alerted method as well, gm.alerted. Else, if we're not detecting the player, then we're not in alert, so the alert icon .setActive will equal false. And that is what we need for the raycast for the FOV. Let's save, and now let's head to the game manager script. First and foremost, in the game manager script, we're going to be reloading this scene using scene management. Therefore, we need to make sure at the top we have added using Unity Engine.scene management. Once you have, let's go ahead and punch in really simple variables for a simple game manager. We'll have a public game object for the game over menu and a public bool for paused. To pause the game, let's go into update and punch in an if statement that says if the input.getKeyDown in the brackets keycode.escape. We'll call upon the game pause method. However, we also want to check that if the game is paused, then we become unpaused. Next, let's go into the game pause method and punch in what we need. If game is paused, then pause the game. Else, we're going to resume game. Now, what's going to happen when we resume and pause the game? Well, we're going to change the timescale. For example, to pause the game, we're going to change the time.timescale to 0, meaning we've frozen the time. Then, to resume playing the game, we just need to set that timescale back to 1. So punch in the same line of code and just change that to 1. And there we go, simple pausing mechanic. However, we want to make sure that when we start the game is already resuming and unpaused. So what we can do, just copy and paste the resume game method name and punch it into void start like so. Next, I mentioned we're using scene management to reload the scene. So let's create a public void called retry and let's punch in scene manager.loadScene, then inside the brackets scene manager.getActiveScene.name, meaning this very scene. It's also nice to have the option to quit the game as well. So we'll create a void quit and we'll simply put in the inbuilt function there, application.quit. Now, when the player is detected, let's create that alerted state that we made a reference to in the FOV script. And it's going to be nice and simple. We want two things to happen. We want the game to pause and we want the game over menu to be active. So geomenu.setActive equals true. And that's all we need for a simple game manager. Let's hit save and head back into Unity. Once everything has compiled, let's go ahead and add the field of view script to each of our enemy prefabs. In the prefabs folder, double click the guard, scroll to the bottom, and you can simply drag and drop your field of view in there like so. And we also want to update the alert icon object in the field of view script. So go ahead and drag your alert in there like so. And I'd like you to go ahead and repeat this process for every single one of your enemy prefabs, the guard and all of the cameras. Once you've done that, let's head back into the scene view where we can set up the rest of our components. Next, let's create an empty game manager and let's add the game manager script to it like so. And there you'll see it's asking for that game over menu, which we currently don't have. So let's go ahead and quickly create a simple game over menu. I have here my canvas. To create the canvas, you can either right click, UI, select canvas, or any one of these UI elements, it'll automatically create the canvas. For the game over menu, I want the screen to go dim, display a retry button, and the title of game over. To do that, I'm going to right click on the canvas, go to UI and hit image. I'm going to scale the image up on the X and Y by, I don't know, let's say 20, just so it covers the camera, and let's change the color to black. Below here on the alpha channel, let's dial that down just so we can see the player. There we are, that looks okay. And now I also want to have a button. To create the button, let's right click, hit UI and hit button, and it automatically creates it for us with some text. But it's a bit too small, we can't really read that. So let's go ahead and scale up our button. I'm just going to center align it on the X position by 0. That's big enough. And let's go to the text. Let's change the text name from button to replay. And make sure that our text is center aligned. And let's scale up the font size so we can see it clearly. And it should stick in the center. That will do. And now we want to have a game over title. For the text, right click, UI, and hit text. Let's just position it above the replay button up there. But we can't really see the text. That's because it's too small and the color is black. So it's matching the background too much. Let's change the text name to Mission Failed. And let's go ahead, center align it like so. For the horizontal and vertical overflow, change the wrap and truncate to both overflow. And let's change the text color to white. And let's go ahead and scale it up so we can see it clearly. Just scale up the font size like so. And that will do for our game over. But we also want to make sure the button knows we want to replay the game. So below here, you'll see we have an on-click event. Hit the plus, and it's asking for a script. Go ahead and drag in the game manager object like that, because our replay and reload is on the game manager script. Hit the drop down, select the game manager, and you'll see we have our retry and quit methods there like so. We don't have a quit button right now. You can go ahead and create that if you like. We're just going to deal with the retry button. So when we play the game and we hit retry, it'll reload the scene. That's all we need for the game over script. Let's go ahead and deactivate the canvas. Go to the game manager and drag and drop the canvas in there like so. That's what's going to reactivate when we are detected. Before we go ahead and test, it's very important that we set the player tag to that target object. Remember, we're not going for the player parent, but the target is the base collider. So make sure that you have added the player tag, and you can add the player layer as well to that base collider so the raycast knows it is detecting the player or not. And with that, let's go ahead and hit play. And you can see we've got these green lines. If we zoom out, that is the raycast being shot from the enemies, but you'll notice that the raycast is always aiming down, even though these guards are patrolling to the left and to the right. In order to change the direction of the raycast, we have to influence it in the enemy controller script, because if you remember, the direction the enemies face is based on the direction of movement, which we used the velocity to get. So let's go ahead and quickly open up our enemy controller script and update this. All we need to do is at the bottom of the variables here, just add a serialized field for the field of view script, simply called the FOV. Then let's go ahead and in awake, make a reference to it. FOV equals get component field of view. And next, let's go down into update, and just above where we have this if statement for the 4 directions, let's go ahead and just add another set of if statements. Here we're going to state that if the movement direction or the direction.x is greater than 0, then we're moving to the right. Therefore, the field of view.look direction equals vector2.right. Else, if the direction.x is less than 0, we're moving to the left on the x, therefore fov.look direction equals vector2.left. And likewise underneath, we've done the same for the y-axis. If direction.y is greater than 0, then the fov.look direction equals vector2 up, and the opposite below for vector2.down. This will now help influence the direction we want to shoot the raycast. So let's hit save and let's head back into Unity. Before we do one final test, there is one thing we have to address. Unlike the enemies, our cameras are facing a static direction. They're not going to be influenced by the direction of movement. So all we have to do to make sure the raycasts are being cast correctly with the cameras, select your camera, go to the field of view, and we can manually input the look direction there like so. We don't want it -1 on Y. For this camera, it's looking, if you double click, you'll find out which one it is. It's looking to the right, so I want it to be 1 on the X. This next camera, I'll double click right there. I want that to be -1 on X and 0 on Y. Let me go to my other remaining cameras. They're looking down. So if it's looking down, yep, -Y on the X. And if any cameras are looking up, then that'll be +1 on X, like my camera down here. That'll be my fourth camera. So I'm going to just adjust that like so. He's going to be +1 on X. And now all our enemies, their raycasts will be facing in the right direction. So go ahead, zoom out so we've got a good view of the arena again, and let's give it one final test. You can already see that we have not been detected because we have that debug message, no one there. So let's go ahead and get in front of one of these guards. And you should, there we go. He has detected us. The alert icon is active. Mission failed. Let's hit replay and we're back in the game. Let's go ahead and try out one of the cameras. Let's see how that works. There should be a camera up here. Yep, the camera right there at the top of the screen has seen us. Mission failed, and we can replay once again. And there we go, everybody. We've created a very simple, very basic stealth game inspired by the classic Metal Gear series. You can go ahead and expand on this in any way you like. You can adjust the field of view angle, maybe add an alert state, or you can even visualize the FOV cone if you so wish. If you do, we'd love to hear how you got on, so please do feel free to message and contact us here or on any of our socials. We do read all your comments and we do appreciate your support. If you see the worth in what we're doing, please consider liking, sharing and subscribing to the channel. We do very much appreciate all your support. Thank you all very much once again for watching, and we'll see you next time. Take care.